So this is a piecewise defined function. We're asked to graph, we're asked to look at continuity and differentiability. Three different topics, three different parts here. Okay, so let's start with continuity. For continuity, I will say that x squared plus 1 and 2x plus 1 are continuous as polynomials. And that's good enough. Okay, still in number 1, continuity at x equals 2. I don't know. But I know that the definition says a limit as x approaches 2 from the left from x squared plus 1 must equal limit from 2x plus 1 as x approaches 2 from the right, and must equal f of 2. So the limit from the left is 4 plus 1, which is 5. The limit from the right is 4 plus 1, which is 5. And the function value, of course, it has to be 5, because it's one or the other, and they're both the same. 2 squared plus 1 is 5. So I will conclude continuous on negative infinity to infinity, f of x, everywhere. Now, in step number 2, I will find the derivative of those two branches. So I have here 2x for x less than 2, and I have 2 for x greater than 2. Notice that I don't know what happens at x equals 2. X equals 2. Is the function differentiable? I don't know. So I look at limit as x approaches 2 from the left from 2x. Does this equal limit as x approaches 2 from the right of 2? The answer is no, because this limit is 4 and this limit is 2, and 4 does not equal 2. So we conclude the function is differentiable. This is okay. The function is differentiable, the original function is differentiable, but not at 2. And now in step 3, we're asked to graph the function. We can also graph the derivative. We can do both. So I'm copying the function here, because it's already 3 pages back. So it was x squared, yes, x squared plus 1 for x less than or equal to 2, and 2x plus 1 for x greater than 2. So as I showed when we graph these functions, this is negative infinity to 2 with a bracket, and this is a parenthesis 2 to infinity. The domain is indeed all real numbers. I have to have 0 and I have to have 2. And under 2, I will have this symbol going this way and this symbol going the other way. And they're touching, and they're right under 2. This piece will be using x squared plus 1, and this piece will be using 2x plus 1. So now let's see what happens next. I know that this is a quadratic function. I will plug in negative 1 and positive 1 as well. You'll see why, because these are the x. These are not the x and y intercepts, but I'd like to see it. I know how to graph this, right? So we already know that this is x squared, and it goes up 1, right? This will be x squared plus 1, but I will not be graphing the whole thing. So negative 1, 1 plus 1 is 2, 0 is 1, again 1 is 2, and I plug in 2, and I get 4 plus 1, as we know, it's 5. Same here, I plug in, it's 5, I plug in 3, and I get 7. So here's the graph, and we'll see what happens at 2, and we'll understand why the function is not differentiable at 2. So I already know this is negative 1, 2, and 0, 1, and 1, 2, and a 2, 3, 4, 5. And it is a full point. And here's the graph. I graph this side in blue. And I'm going to graph the other side in purple. So a 2 is 5, and a 3 is 7. So please make sure that you're not extending the blue graph to the right of 2, and make sure you're not extending the purple graph to the left of 2. That would be a terrible mistake. So as you see, there is a tangent here and a tangent here, and they're not the same. This one has slope equals 4, and this one has slope equals 2. That's why there are two tangents, and this is a so-called corner. That's why the function is not differentiable there. So this is the function, oops, it's f of x. Now if I want to graph right underneath, completely underneath, to have the same points everywhere, here's what happens. Here at 2, this is 2. At 2, one side is 2. And the other side I'm graphing this. So this is 2, and on this side is 2x. So when x is 0, y is 0, and so on and so forth. And it goes to it goes to 4. This is the graph of the derivative. As you see, the derivative has a gap, has a jump. It's not continuous at 2. Because on this side, the slope is 2. And on this side here, as you see, on this side, the slope is 4. That's how we got the limit from the left to be 4. And the limit from the right to be 2. Whenever the derivative is not continuous, at the point where the derivative is not continuous, the function is not differentiable. Very good question, thank you. Do you understand why we have to graph them one below the other, so we can see exactly what happens at this point? So the rest is fine, but especially this one is very important. So you see 4 from the left, 2 from the right. Good. Next question, please. Anything you like. You can look at the test. They're basically a test and a half for this midterm. That's why I posted all 3. Any questions on this problem? Please look at the piecewise defined functions we graphed. So you don't make the error, as every class, I have at least one student who will graph something like this for this function. Graph like this, and then graph like this. You understand that this is not even a function. By the vertical line test, it's not even a function. So please do not do this. Notice each piece. That's why I specifically wrote it at the top, so I don't make an error and be tempted to extend anywhere. That's why I even use 2 different colors in all my classes, to make sure that this is this part, and on this part is this. Good. Next question. Anything else you'd like to go back to? Any topic? Oh, I chose that function. Oh, good pick for me.
Can you choose, like, can you do one with where it talks about the average rate of change?
Sure. So let's just make one up. So let's have, we have a function, let's say it's f of x equals 2 minus x over x plus 4. And let's make up a point. I'm going to choose 0. 0, 0, 2 over 4, 1/2. And let's choose another point. I'm going to choose 1. 2 minus 1 is 1, 1 over 5. So let's say we want to determine the average rate of change between these 2 points, 0, 1. So this is just the slope, y2 minus y1 over x2 minus x1. So basically I have 1/2 minus 1/5 minus 1/2, so this is denominator 10. This needs a 2 and this needs a 5. 2 minus 5 is negative 3. So you either leave it as negative 3 over 10 or negative 0.3. What about the definition of the derivative, with the limit of the difference quotient? Was this what you had in mind with the average rate of change?
Like from, I think it was from last class when we had the little short quiz at the end.
Oh yeah, let me look. What was the problem? Yeah, sure. What was the problem?
It was like, it was negative 0.001 plus, t, sorry, that's t to the third power plus 0.1 t to second power. And then I think it was like how many, like how much can you memorize in like 10 minutes or 10, something like that.
Yes, so that will be m of 10. So you put in the graphing calculator, negative 0.001 multiplied by 1,000. I shouldn't be doing this with the calculator, but I'm showing this to you. Sorry about that. So it's 9. But the rate of change after 10, right? So the rate of change is m prime of t, which will be negative 0.003 t squared plus 0.2 t. And what are we asked to plug in? Also 10? After t?
Yeah, I think so. It was 10.
Okay.
Sure.
So 1.7. And that is words per minute. So please always write the measurement unit. Without the measurement unit, you cannot get full credit. Also, please do not use those calculators like 91, TI 91, 89, etc. Because if you have 15 minutes to upload the work, if your work does not justify every step, I cannot possibly give credit for it. So do not use these calculators. And careful, because Anulak will flag your tests. And if they do flag your tests, I have to carefully look and see why. And I may not be able to give a grade.
Okay, so for uploading it to how we got our...
Yes, it has to be a PDF file. It has to be one page. You can have 15 pages in here, but one PDF file.
Okay.
I meant to say.
When we upload it, can we just use like Adobe Scanner to just upload that?
I think so. As long as I can open it, because if I can't open it, again, I will have a problem. If it's not a PDF file, I will not be able to upload it. Just make sure that it's a PDF file and double check.
Yeah.
And make sure it's clear. And make sure that when you write the test, it's very clear going from problem to problem. Let's say problem 1, solution. Problem 2. So I know where one starts and the other one ends. If I have difficulties understanding your work, you may miss points, and I don't want that. I want to give as many points as possible.
So if we're doing something in the calculator, do we just say like what part it was, or be like, use the calculator for this?
Well, so for example, here is very clear. You don't have to show me that you're putting in here 10 squared and so on and so forth. But if, for example, you get from the second derivative the sixth derivative right away, then I know something went wrong if I don't see all these steps. That's what I mean. Good. Next question. Question or topic, please choose. Anything else you'd like to ask? Problem or topic? Please rewatch the videos just to make sure you see how the work has to be presented.
Which videos are you talking about?
Okay, so let me share my screen. So I'm clicking to make sure that I got what you need. Okay, so right here at the top in our Canvas course, I presented those tests with solutions. And here there is a folder entitled Video Lecture and Lecture Notes Fall 2020. The entire class is here. Everything I said, everything I wrote. So last time I had 4 videos that I created, and this is the PDF file, what I just reviewed with you at the beginning of the class. All these videos are in YouTube. If you click on any of them, you go to the top, and here it is. I didn't mean that. I just meant, I'm not sure what this is. It's somebody else's. It's not mine. I don't know what that is. I just only meant to mute myself. That's all I was trying to do. So all the videos, I have, as I mentioned, 2 cameras, 2 webcams. One that you see what I write, and the other one I record. So you have everything I've ever done in this class. And if I realize that I missed a minute or 2 or something, then I went back to express in words what was happening. So you have everything. And back to modules. Everything we've done is here. From day 1, I post them right after class because I have to delete them. These are huge files on my computer, and if I don't delete them, then I will not be able to record the next class. So I have to upload them right away and then delete them from my hard drive. So if you need to go back and rewatch any particular topic, look at the PDF file and just watch the one that you need. You don't have to watch. I had to break them down into 20-minute, roughly, length because it takes a long time to upload. From school, I was able to upload an hour video in 7 minutes. But at home, it takes me about 15 minutes to upload a 20-minute video. So that's why I'm so sorry I had to break it up into 3 or 4 sometimes. Good. Next question or topic? Anything?